So, good day everyone. So, this would be our synchronous session for our topic which is all about the sun. So, bakit po nag-asynchronous class? Kasi kung makikita natin sa ating calendar of activities, the whole month of June, lalong-lalo na yung Monday ay punong-puno ng mga activities natin. So, mahihirapan po ako makapag-conduct ng face-to-face classes and ayoko rin naman po kayong maagrabyado at lalo baka hindi ko nga maituro ito face-to-face. So, ang ginawa ko pong remediation is that I will now conduct series of lectures like this. And I hope that this would help you understand more about our lesson sa astronomy, sa subject nating astronomy. So before I continue, let me check my audio and visuals muna sa ating channel. So far, okay naman siya. So just give me a minute so that I can officially start my lesson right now. I hope it's up and running na. Check na natin. So again, magandang hapon po sa aking BSED3S science students. And our topic for the day will be all about the sun. So this one is actually, maganda ito kasi last time, di ba nakapag-observe tayo. I hope di ko sure kung nakapag-observe. Yes, nakapag-observe kayo ng solar eclipse. And at least you have seen the phenomenon na tinatawag nating solar eclipse. So tingnan natin, ano nga ba yung sun? Why is it so special to us? Okay? So the topic outline for our lesson for this day will be all about solar processes and solar features. Okay? So the sun began to shine about 4.5 billion years ago when gravitational contraction made its core hot enough to sustain nuclear fusion. So just like what we have discussed earlier sa modern physics na topic natin, our solar system started around 4.6 billion years ago, and from that point, nagsimula na yung ating sun to shine. So hanggang sa ngayon, the major source of energy sa ating solar system will be our sun. And due to this gravitational contraction and making this core ng ating sun na sobrang init, it helped this one to sustain its nuclear fusion. Tandaan natin, lilinawin natin, ang ating araw, it's not a ball of flame. Hindi siya apoy. Okay? It's actually the manifestation of nuclear radiation or nuclear fusion na nangyayari sa ating sun. Okay? It has shined steadily ever since because there are two types of balances na nangyayari sa ating sun. It's all about gravitational equilibrium and energy balance. So how are these two balances help facilitate the sustenance of the processes that's happening inside our sun? So this one, magandang animation to showing you the rotation of our sun, showing some of the features, mga unique features na meron sa ating sun. Actually, this lesson is also applicable to other types of stars. So next week, ang discussion na lang natin sa face-to-face will be the stellar properties like luminosity, apparent brightness, apparent magnitude, yung mga ganun topics na lang. So ito, more on the processes itself. Ano ang nagaganap sa mga stars natin? Okay? So pag sinabi natin gravitational equilibrium, from the name itself, equilibrium meaning balance. So gravitational equilibrium is only achieved if there is a balance between the outward push of pressure and inward pull of gravity. That's always the case naman eh. Okay? There's an inward pull of gravity and there's an outward push of pressure. And once na balance itong dalawang forces na ito, itong pressure and gravity na to, okay, there is what we call gravitational equilibrium. Pag sinabi naman nating energy balance, it's between the energy released by the fusion in the core and the energy radiated into space. So kailangan balance lagi itong mga bagay na to. If we have balanced the pressure and gravity and the amount of energy produced in the core and released into the space, we are going to achieve what we call gravitational equilibrium. And that makes our sun stable for now. For now. Kasi after billions of years, hindi na ganyan ang sitwasyon. May ma-overcome tayong mga forces, kaya ang mangyayari sa ating sun, it will expand, it will become larger. Okay? So, sabi ko nga po kanina, the sun is not a ball of flame. Okay? The sun is a giant ball of hot plasma. So, pag sinabi nating plasma, it's a type of gas wherein most of the atoms are ionized, meaning charged. So lilinawin natin ulit ha, kapag kayo ay nag-explain sa mga students natin, hindi bola ng apoy yung araw natin ha, it's a ball of hot plasma. Pag sinabi nating plasma, it's gas in ionized form. Okay? And usually occur in higher temperature. The differing o yung pagkakaiba ng temperature and densities of the plasma at different depths gives the sun the layered structure. So parang may structure, mayroon pa rin, parang Earth din yung ating sun. Meron din tayo siyang crust, may ganun din siya. Pero this one is more defined. Ito ay it is defined by the temperature and densities ng mga material na nasa ating araw. Hindi katulad ng ating Earth na yung crust natin more on silicon, yung mantle natin molten rocks, yung core natin na iron nickel core like that. Pero sa ating sun, it's more on plasma. Okay? And this diagram is a good, tanggalin ko lang muna yung mga pop-up na ano natin dito. Okay? As you can see here sa ating diagram, the plasma here occurs at higher temperature and higher pressure. Okay? So ganyan po ang sitwasyon sa ating araw. So, obviously, since I have mentioned earlier na yung sun natin, it's the major source of energy sa ating planeta. And the sun releases an enormous amount of radiative energy in joules into space. I hope you can recall na yung unit of joule is the unit of energy. Okay? So, aside from that one, kung gusto naman nating alamin kung gaano karaming enerhiya ang napoproduce ng ating araw sa certain period of time, we are going to use the variable called power. So watts naman. So pwede natin gamitan ng watts or joules per second ang energy na nare-release o napoproduce ng ating araw. So the sun's total power output or luminosity is an incredible 3.8 times 10 raised to 26 watts. I think if you're going to compare that one to the electrical consumption ng ating planeta, it can power our planet for billions of years. Ganun kadaming energy na po-produce ng ating araw sa kada oras na yan. 3.8 times 10 raised to 26 watts. So, linawin lang natin kasi baka malito kayo sa term na luminosity. Ang unang iisipin natin kasi pag sinabi nating luminosity, liwanag. Pero sa totoo lang, if you're going to define luminosity, is the total power output. Gaano karaming enerhiya, gaano karaming power ang napoproduce ng ating araw per unit of time. So it corresponds to its luminosity. Okay? So klaruhin lang natin yung term na yun, ha? We will not go into this math, tong geometry, paano kino-compute yung total energy or total energy output ng ating sun. But to give you an idea, obviously, even at small space or small area, our sun radiates or produces lots and lots of energy. So yung ating araw, it's a ball of energy sa totoo lang, kung tutuusin. Okay? So here are some of the properties, structural properties or structural measurements ng ating sun. The radius of the sun is 696,000 kilometers. So it's about 109 times the radius of the Earth. Imagine yung lapad ng ating Earth, yung ating sun. The mass of the sun is 2 times 10 raised to 30 kilograms. So it's 300 times the mass of the Earth. Luminosity, as mentioned earlier. And the main composition of our sun is 70% hydrogen and 28% helium. Now, sir, nasan yung 2%? The remaining 2% are the heavier elements. And sa astronomy, pag sinabi nating heavier elements, these are not metals. These are elements heavier than helium, like lithium, boron, carbon, which kung tutingin natin sa mga chemists, kung tatanungin natin mga chemistry major, they will tell you na, magagaan din naman yung mga yan. Pero sa astronomy, pag sinabi nating heavier elements or heavy elements, this pertains to elements heavier than helium. So starting from element number 3, moving forward hanggang kung kailan man tayo aabot. Okay? The rotation rate is 25 days at the equator and 30 days at the poles. So parang Earth din, mas mabilis sa equator, mas mabagal sa poles. The surface temperature, which is 5,800 Kelvin at average, and cooler sa mga sunspots natin. Right now, may article ako nabasa na yung sun natin is in active period na kung saan may sunspot siya na kasing laki ng 4 na beses ng ating daigdig. Imagine the size. At hindi ko lang sure kung confirm nga yun na kahit wala kang telescope, you can see those sunspot with using a solar eclipse glasses. Itatry ko pa lang siya actually this weekend kung kita nga talaga tong sunspot na ito. The core temperature is 15 million Kelvin. Imagine the temperature. 15 mas appropriate sa mga measurements ng Kelvin in this case. Okay? So, moving forward. So, one manifestation ng activity sa ating araw is the solar wind. It's a stream of charged particles since nga yung ating araw, it's a ball of charged particles and they're continually blown outward in all directions from the sun. Malas natin kapag tayo ay tinamaan itong solar wind na ito, lalo kung may mga coronal mass ejections. And that's the reason why kung bakit meron tayong aurora sa North and South Pole, aurora Okay pa. Anyway, so I think it's okay pa naman yung internet connection natin kasi nakakapag-ano pa ako. Yung live stream lang yata sa YouTube ba naging problem. Ayun, so far okay naman. O, buti naman. Buti konti na lang to. Anyways, class, so thank you for bearing with me. Ayan, balik lang ako sa aking platform. Wait ko lang na mag-flash ulit. Hopefully, hindi na apektuhan yung discussion kanina. Check ko lang ha. Check ko lang. Parang may uulitin akong part sa aking discussion kasi hindi lang, hindi lang guys. Hopefully, ayun, mukhang may uulitin nga akong part. Anyways, go. Balikan lang natin. Ayun, 2 slides na naman pala. Ayun, mukhang may uulitin nga akong part. Anyways, go. Balikan lang natin. Ayun, 2 slides na naman pala. So, balikan lang natin na doon, naririnig niyo naman yung audio ko doon, but the visuals are not okay. So anyway, so in this case, yung sa solar wind natin, these are stream of charged particles that are continually blown outward in all directions from the sun. And sometimes itong solar wind na to can correspond to coronal mass ejections or CMEs. And the CMEs are very dangerous sa ating planeta kasi it can disrupt the transmission ng mga satellites natin. Yan ang kinakatakutan ng mga mga broadcasting agencies natin, yung coronal mass ejections na yan. Luckily, yung mga recent na coronal mass ejections hindi tumatama sa ating planeta. Wag naman na sanang tumama sa atin kasi pwede niyang sirain talaga yung mga gadgets, mga devices natin, yung mga signals, transmission, wifi, yung mga bluetooth, ganyan, pwede niya sirain talaga yun. And luckily rin, yung ating planeta ay may sariling magnetosphere, which actually protects us from this very harmful coronal mass ejections. So, mag-share po ako ng isang link later galing sa NASA. Pwede niyong sagutan yun na kung saan makikita niyo yung effects ng solar storms sa ating planeta. Okay? So, tawag dyan mga solar storms. Okay? So, nabanggit ko rin yata, ayaw kong patapusin. Okay, moving forward. So, yan. I think na-discuss ko na itong part na ito. Ayan, so in this case, napaliwanag ko rin po kanina without the visuals nga lang. Yung corona, it's the outermost layer of the sun, but it's the hottest layer of the solar atmosphere. As we go deeper, as we go towards the interior of the sun, papuntang photosphere, the visible area ng ating sun, it becomes colder at 6,000 Kelvin. Okay? Sige, pahapain ko lang yung internet connection na ito. Don't worry guys, ibibigay ko naman sa inyo itong PowerPoint presentation na to so that you can, pwede nyo sabayan na lang para at least kung sakaling nagkaroon ng problema sa pag-flash ng ating visual sa ating presentation, sa ating live stream. Pahinga muna tayo. Ayaw makisama ng ating internet. So, itong mga lessons natin so far sa ating sun is magagamit natin sa next discussion next week sa Monday, which is all about the stellar properties. Ano yung what is apparent magnitude, apparent brightness, luminosity, surface temperature, color. So, yun ang titingnan natin sa ating discussion next week. Ayan. So, okay na ulit. So, bilisan na natin at ayaw makisama ng internet. Anyway, so, convection zone, yun nga sabi ko nga po, warm material or hot material will rise and the cool material will sink through the process called convection. So, deeper, we have the radiative or the radiation zone. Ito po yun, sa ilalim ng convective zone. And it's even hotter. It's 10 million Kelvin. At dito nagaganap yung outward push or outward movement ng photons of light that actually escapes later sa ating araw. And at the core ng ating araw, it's 15 million Kelvin. Okay? It's the hottest area of the sun, and it is where nuclear fusion transforms hydrogen into helium. So sa totoo lang, hindi siya katulad ng Earth na ang daming proseso, may erosion, weathering, at kung ano pang mga geological and mechanical processes. Pero sa ating araw, it's basically the the nuclear fusion wherein hydrogen is transformed into helium. Yun lang po yung nagaganap halos sa core ng ating sun. It's very basic, very simple yung mga kaganapan sa ating sun. And basically lahat ng stars ganun din halos lang ang nangyayari sa core. Okay? So, nabanggit na natin yung nuclear fission and fusion. Pag sinabi natin yung nuclear fission, it's the process wherein the nucleus splits into smaller nuclei. While nuclear fusion combines smaller nuclei into larger nucleus. So ito yung nagaganap sa ating sun, nuclear fusion. Okay? Smaller nuclei will combine into larger nucleus from hydrogen to helium. Sa Earth, we can actually do these two things. Kaya lang, sa mga nuclear power plants natin, we're going to have fission only. By the way, itong nuclear fusion and fission will be further discussed sa subject nating modern physics at aaralin natin paano nangyayari itong nuclear fission and fusion. Okay? So, sa ating core, sa ating loob ng ating araw, ganito po, simulan nating aralin na paano nakakapag-produce ng streams of photons ng ating araw. At any one time, some of these nuclei are on high-speed collision courses with each other. Para silang mga bola ng bilyar na hindi nila may iwasan na magbungguan or magtapatan. In most cases, electromagnetic forces deflect the nuclei kasi repulsion forces. Di ba, pag sabi natin positive to positive, they will repel each other. Negative to negative, they will repel each other. And since nuclei are generally positive particles, they will repel each other. Pero, mangyayari lamang itong collision or itong pagsasama na ito if there is a sufficient energy sa mga particles natin at pagtama nila sa isa't isa, they will stick together to form a heavier nucleus. So ito yung basic principle ng nangyayari sa loob ng ating sun. Okay? If the atomic nuclei has sufficient energy, most probably once na sila ay nag-collide, they will stick and form a heavier nucleus. So dito papasok yung tinatawag nating proton-proton chain. Ito yung nagaganap sa atin. Ito magandang animation to. Ito nakita ko sa internet na pinapakita kung paano nakakapagbuo ng hydrogen into helium. So wait lang natin ulitin yung animation ha para ma-explain natin mabuti itong proton-proton chain na ito. Okay. Let's wait for that one to repeat. Ayan. So as you can see here on the first slide, we can see that the proton and neutron fuses releasing two particles of radiation, like beta particle and gamma particle. So we have the next one, na collide sa kanya yung isang proton. And once na nangyari ito, marirelease yung isang gamma ray. Okay? And then if we have similar nuclei, dyan mapo-form si helium. Okay? Medyo mabilis pala yung animation. Anyways, meron akong still na diagram dito para ipaliwanag itong nangyayari sa proton-proton chain. So let's see this one. So during step 1 ng hydrogen fusion by proton-proton chain, two protons fuse to make a deuterium nucleus. Okay? So yung deuterium nucleus natin, it has one proton and one neutron. It is still hydrogen. Okay? It is still hydrogen. And but this time it has a neutron na. Okay? This step occurs twice in the overall reaction. So as you can see here sa ating diagram, yung pag-fuse o yung pagbungguan ng dalawang protons natin, yung isa dyan magko-convert na mata-transform into neutron, producing a hydrogen nuclei. So itong hydrogen nuclei nito, this is deuterium na. One proton, one neutron. Then on step number 2, the deuterium nuclei or nucleus fuses with another proton. Siyempre, in a high-speed collision yan, parang bubunggu ulit, and they will now form helium-3. This is not the stable form ng helium natin. Ang stable form ng helium natin is helium-4. Don't worry, mas ma-reinforce natin tong topic na ito once we now discuss nuclear physics in the coming days sa modern physics. Maaral natin kung paano nangyayari ito. Then once na meron na tayong helium-3 nucleus, we have 2 protons and 1 neutron, magpunta na tayo sa step 3, na kung saan dalawang piraso ng helium-3 nuclei fuse to form helium-4 nuclei. Okay? Then after that one, it will release 2 excess proton in the process, which in turn can collide again and go back or magsisimula siya sa step 1 ulit. So, napansin nyo, it's a chain of reaction. Tuloy-tuloy lang po mangyayari sa ating sun as long as may supply pa rin tayo ng hydrogen. So, yan yung limiting factor. As long as may supply tayo ng hydrogen, magpapatuloy ang proton-proton chain, mabubuhay pa rin yung ating sun. In some types of star, limited yung supply nila ng hydrogen o yung mga protons na yan that will be used in this proton-proton chain. So, madaling namamatay yung mga stars na yon. So next week, i-discuss natin anong klaseng star yung matagal mabuhay, matagal mamatay. Swerte na lang natin na yung araw natin o yung sun natin, nagsimula siyang medyo, sabi natin, mabagal yung kanyang proseso, kaya mahaba ang buhay niya, kumbaga. Pero may mga stars tayo na in an instant, they will die kasi limited ang supply ng kanilang energy. Limited ang supply ng kanilang mga protons to start this reaction. So this one, medyo complicated tong part na to. This one just shows us that there are different forces or processes that is involved in maintaining and regulating the thermostat ng ating sun. Once na nagkaroon ng imbalance dito sa mga kaganapan na ito, itong mga gravitational equilibrium, mga pressure, mga forces na yan, maaaring mag-expand na yung sun natin and move to the next part ng kanyang buhay. So for now, tuloy-tuloy pa rin nare-regulate ng solar thermostat, yung gravitational equilibrium, kaya nasa main sequence pa rin yung ating araw. Okay? Pero huwag kayong mag-alala, hindi naman yan in an instant magiging red giant yung ating star, yung ating sun. It will take, I think, 2 to 3 billion years from now pa. So, huwag na natin intayin. Masyadong matagal yun. Billions of years pa yun in the future. Okay? So, this one, so maliwanag sa atin na nuclear fusion is the source of all energy in the sun and it is usually released into the space. So yung energy na yan yung natatanggap ng ating planeta. Okay? If the fusion rate varied, so would the sun's energy output. Obviously, kapag nagbago yung fusion rate na yan, mas tumaas yung fusion rate, magbabago din yung energy output ng ating sun. And their large variations rate gradually rises over the billions of years. So habang tumatanda yung ating araw, magbabago din yung rate ng fusion natin. Okay? This rise in the fusion rate explains the gradual brightening of the sun with time. So habang tumatanda yung sun natin, liliwanag yan. Yun nga lang, once na lumawanag yan, tatanda yung ating sun. Ito na yung sinasabi ko kanina, yung pinball. Parang pinball effect na nangyayari sa ating sun. So, to give you in detail, energy moves through the deepest layer of the sun. So yung energy na yan, nagsisimula yan sa core ng ating sun. It will pass through the radiation zone na kung saan magkakaroon tayo ng tinatawag na radiative diffusion. And at this point, para siyang pinball effect na. Magbabounce yan, magko-collide yan sa iba't ibang particle until such time that this energy escapes the sun. So, kaya lang, itong energy na ito na na-produce sa ating core, bago siya makarating sa surface ng ating sun at makawala sa outer space, it will take hundreds of thousands of years. So, ibig sabihin, yung sunlight na natatanggap natin sa ating planeta, it's a very old sunlight na. Hindi siya na-produce ngayon. Nag-release lang siya ngayon. Yes, that's true. Pero yung production niya, it would take thousands of years ago bago siya nung na-produce siya. So, matandang sunlight na yung nakikita natin or nare-receive ng ating planeta. So, yung pinball na yan hanggang sa makarating at maka-escape. Hopefully and luckily, naka-escape yung light na yan and that will be received by the objects surrounding the sun na yan. Okay? So ito naman yung nangyayari, ito yung mga processes. This one is what we call the convection. Uh, Kasama ng rotation ng sun, ito yung nagdudulot ng mga solar activities na nakikita natin. So this is what happens inside the photosphere of our sun. And as you can see here, ganito para siyang batik-batik, para siyang mosaic yung ating surface ng ating araw. And this whitish area na to, dito umaangat yung mainit na material, and the cooler gas are the darker regions. And even darker are the sunspots. Later ipapakita natin. And at this point, kung saan magkakaroon ng mga sunspots, typically ano siya ng magnetic field. Okay? These contortions of the magnetic field are responsible for phenomena such as sunspots, flares, prominences, and coronal mass ejections, and for the heating of gas in the chromosphere and the corona. So yung mga corona na yan, yung mga prominences na yan, yung mga flares na yan ay dahil sa magnetic field ng ating araw. Okay, so i-zoom natin tong diagram nito. Let's see. Ayan. So in this case, makikita natin sa ating diagram that the photosphere is 5,800 Kelvin, sorry. And the sunspots are colder, 4,500 Kelvin. It corresponds to the area na kung saan may sinking ng material, kaya mas malamig sa mga areas na yan. And below it, we have the convective zone, kaya siya may mga convection cells. The magnetic field of sunspots suppresses convection and prevents surrounding plasma from sliding sideways into spots. So, parang siyang loop. So, mapapansin niyo kadalasan sa mga sunspot natin, they move into pairs. Lagi sila halos karamihan ng mga sunspots natin may mga pairs. And that one, this magnetic field traps gas. Okay? So, ganyan po yung, and this one is manifested like this one. So, may sunspot dito, may sunspot dito sa dulo na to. They will form this manifestation ng mga magnetic fields na yan. So, based sa physics, so magnetic fields are invisible, pero pwede nating i-represent sila by drawing magnetic field lines. And the lines are close together where the field is stronger and farther apart where the field is weaker. Okay? So, charged particles such as the ions and electrons in the solar plasma cannot easily move perpendicular to the field lines. So, nangyayari dyan ngayon, yung movement ng mga particles natin sa magnetic field line, they are not moving like cars sa highway natin. They will be spiraling through this invisible magnetic field ng ating araw. Ulitin ko ha, they will not move like cars in highways, but instead they will just spiral through this magnetic field lines na ito. Okay? Nung inaral namin to last time sa space science na subject ko sa astronomy, may mga kinocompute dyan, may mga uri pa yan. May mga uri pa ng mga movements, may mga distances, i-check kung paano nag-move yung mga particles na yan. It's actually a little bit complicated sa part na natin na aralin pa ito. Since pag nagpunta kayo sa junior high school, sa grade 9, ang ituturo nyo lang naman dyan is sun is it's the main source of energy sa ating planeta. It's an example of main sequence star. So, mga basic information lang naman. Pero mahalagang alam nyo kung paano nag-move yung mga particles na yan sa magnetic fields ng ating araw. And this magnetic field, ang manifestation niyan will be our sunspots. These are cold regions ng ating araw. Okay? So, 4,800 to 4,500 Kelvin. And in this case, ating picture, pinapakita nito yung two large sunspots. And some sunspots are actually even larger sa ating planeta. Yung ngayon, yung nabanggit ko nga kaninang sunspots, they are 4 times the size ng ating planeta. So imagine the size ng mga sunspots na yan. At yung mga solar scientists, they try their best. They are actually regularly monitoring the presence of the sunspots na to. Binibigyan nila ng mga pangalan yan, mga codes, kung saan nag-a-appear yan. Okay? So yun yung inaral din namin last time. May mga uri din ng sunspots, may mga orientation, may mga classifications, categories. So, hindi na natin iyan pa yun. Okay? I think we're almost done with our lecture. So, in some cases, may mga case po tayo na yung ating mga loops ng magnetic field, they are disrupted and they are being released outward sa ating space. Bursts of charged particles ejected from the sun during periods of high solar activity can hamper radio communications. Ito yung sinasabi ko last time, kani-kanina lang. Na once na nailabas itong mga coronal mass ejections na to, these are large bursts of charged particles. pwedeng makasira ng mga radio communications, electrical power generation, and even damage orbiting satellites. So yan ang iniiwasan natin. By the way guys, ito yung sinasabi kong coronagraph. Tinatakpan niya yung disk, kaya itong nakikita natin parang mga spikes surrounding this disk is the corona ng ating sun. So tinatakpan itong solar disk na ito yung very bright region ng ating araw. Okay? So ito, this one is as large prominence. Ayan, kitang-kita natin yan. And this one, a gigantic solar prominence erupts from the solar surface. This was taken December 8, 2011. And the size of this prominence is 20 times the diameter of the Earth. Imagine that one. Okay? I think this is the last, hindi ba? Last two slides pala. So yung mga sunspots na yan, they are not random, na bigla na lang susulpot sa ating araw dahil may magnetic field na present. No, they occur in patterns. And as you can see here, let's check this one. The sunspot cycle, or the variations in the number of sunspots on the sun's surface, has an average period of 11 years. Average period. So para siyang alon na pwede nating sundan yung activity ng sun. The magnetic field flip-flops every 11 years or so, resulting in a 22-year magnetic cycle. So parang nagkakaroon ng magnetic field, nagpi-flip yung ating magnetic field ng ating sun, and it's being shown, kitang-kita yan sa ating mga sunspot. Okay? Zoom lang natin tong part na ito. Ayan. So in this case, on the x-axis we have the year, and on the x-axis we have the percentage of sun surface covered by sunspot. And mapapansin natin, if you're going to account the number of years, mapapansin nyo na may cycle siya. And ang maximum nito ay nangyari 1960, and so every 11 years nangyayari po itong mga sunspots na ito. So ang tawag sa time na kung saan mataas ang activity ng mga sunspot ay tinatawag nating solar maximum, and the point na kung saan mababa or medyo laylo yung ating mga sunspot ay tinatawag naman nating solar minimum. Ito naman, pinapakita ng butterfly graph na ito yung presence or appearance ng ating mga sunspot para sa mga butterfly kasi. So this one ay yung nasa gitna equator natin. So typically, nag-i-start yan sa equator, moving up, then babalik ulit yan. So it's also a cycle. Sunspots groups shows up closer to solar equator later in each sunspot cycle. So para silang up and down yung mga sunspots na yan. They will start at the middle, they will rise the northerly latitudes and southerly latitudes, then go back to the equator. So on the last part of our slide, we have yung sunspots natin first appear at mid-latitude, that's solar minimum. Okay? And it becomes increasingly more common near the sun's equator as the next minimum approaches. So para silang cycle. Okay? So again, we will start, the first sunspot will appear mid-latitude as solar minimum. And then, uulit lang ulit yan sa next minimum natin. The number of sunspots can vary dramatically from one cycle to the next, and sometimes sunspots seems to be absent altogether. May mga cases talaga na pag nag-observe yung ating mga astronomers, wala silang ma-detect, wala silang ma-observe na sunspot. Okay? So behave yung ating sun, kumbaga. Pero ngayon, every day, there are lots of sunspots that's actually forming. Kaya lumalabas na very active yung ating sun ngayong araw nito. So, to end this discussion, tandaan po natin na itong mga dinidiscuss natin na ito rin po ay applicable sa mga stars sa ating sa universe natin. Okay? Kaya nga alam, may mga special types of stars. At yan yung titingnan natin next week. Ano yung mga properties ng stars, like luminosity, magnitude, apparent brightness, surface temperature, color, yung mga ganyan. Yun yung titingnan natin sa susunod na discussion natin. Okay? So, I hope you learned something about our sun, pero tandaan po natin, pag nagturo kayo sa junior and senior high school, magandang ipaalala sa ating mga estudyante na yung energy ng ating araw ang major source ng energy sa ating daigdig. May it be directly or indirectly nakukuha natin yung energy na yan. Ang point dyan is that most or majority of the processes, may it be physical, chemical, geological, biological processes, ang energy na yan ay galing sa ating araw. So mga major concepts yan sa science na sana maipaliwanag natin mabuti sa ating mga future students sa junior at senior high school. Okay? So that ends my presentation. Okay? So I hope you learned something today. Isa-send ko na lang po itong link na ito sa ating GC, sa ating Facebook GC. para pwede nyo panoorin during our free time. So next week, stellar properties po ang pag-aaralan natin. I think that's the second or third to the last topic natin sa ating subject. And please also get ready with the 5 groups na magpe-present. Yung magpe-present ng Jupiter, Saturn, Uranus, Neptune, at saka dwarf planets. So we will try our best to fit all 5 groups on Monday para matapos na natin yung isa sa mga final requirements nyo sa aking subject. So I hope to see you next week, Monday, sa ating subject na astronomy. So maraming salamat and goodbye.